Hi, in this tutorial I'm going to explain how the Beet pipeline works, and I'm going to go over every single option in the config file. When you run the build command, Beet creates a pipeline and a context object. Then the pipeline calls every single plugin with the context object. So this context object is pretty interesting because it gives you by default a blank resource pack and a blank data pack. So your job is, when you get a hold of this context object, is to put stuff in there. You might have noticed that in addition to the data pack and the resource pack, you can change the name of the project, the description, the author, the version. You also have access to the directory of the project, and this is useful if you want to load additional files in like custom formats and stuff. You also have the output directory to generate things alongside the resource pack and the data pack. The meta attribute lets you store things for the entire duration of the build, and the cache lets you store things across builds. And you also have a quick reference to the template manager if you want to render strings and stuff. So the interesting thing about the Beet pipeline is that it gives you a powerful composition model for applying modifications to this context object. In this example, I'm using the pipeline option to specify an import path to each plugin. So when we build the project, we're going to see plugin 1 and plugin 2 in the console. And this by itself is pretty straightforward, but there's another feature that you might want to take advantage of, and it's the fact that plugins have an entry phase and an exit phase. Plugins can return generator objects, so you can use the yield statement to define an exit phase. If we build the project, you're going to see that the exit phase of the plugin 1 happens after the entry phase of plugin 2. We can do the same thing to plugin 2, but you're going to see that because plugin 1 is executed before plugin 2, it completely wraps the plugin 2. So the entry phase happens before the entry phase of plugin 2, and the exit phase happens after the exit phase of plugin 2. So you can think of the pipeline option as defining layers. Everything that happens in plugin 2 is wrapped by everything that happens in plugin 1. Now I'm going to show you how this works with plugin dependencies within the pipeline. So we're only going to load plugin 2, but we're going to say that plugin 2 requires plugin 1. And this actually doesn't change the output, because when you require the plugin, it executes the entry phase of the plugin, and then it's going to schedule the exit phase of the plugin to be executed after the exit phase of the current plugin. So we end up with exactly the same output. Okay, so now that we have a basic understanding of the pipeline, I'm going to focus on all the options that you can use inside of the config file. And to do that, I'm going to only keep plugin 1, and I'm going to make it so that it creates just a simple function in the data pack. So by default, when we run this, nothing happens, but if you would have linked this project to Minecraft, it would have updated the data pack. We can use the output option to define an output directory, and this will allow us to see exactly what is being generated. So inside of this directory, we have the demo data pack with our Minecraft function. Beet only generates a data pack if it's not empty. Same thing for resource packs. So because our plugin only creates a function, the resource pack is empty at the end of the build, so no resource pack is generated. Now, the name of the resource pack and the data pack depends on the name of the project. The name of the project by default is the name of the project directory, but you can change this with the name option. So when we run the build, we're going to see that next to the original demo data pack, we have other data pack. You can add a description to your data pack and your resource pack at the same time with the description option. As you can see, the description shows up here. You can also use the config file to specify a project author and version information. As you can see, when you specify version information, the version is actually present in the name of the data pack and the resource pack, and it also appears inside of the description. You can also have your own data pack naming scheme and input the description manually using the data pack option. As you can see now, the data pack is called thing, and the description is exactly what you specified in the description option. If you're also generating a resource pack, you can do the same thing for the resource pack with the resource pack option. So as you might have guessed, the data pack and resource pack configuration are exactly identical. So I'm only going to keep the data pack configuration. If you want to specify the pack format explicitly, you can use the pack format option. As you can see, it shows up here. You can also specify whether the data pack or the resource pack should be zipped or not. So if we say zip true, now the data pack will be zipped. So we have think.zip. Next, you can also use the individual data pack and resource pack option to load existing data packs and resource packs. So here, let's say that we have a data pack inside of an src folder. If we run this, as you can see, the function was loaded. So you can load as many resource packs or data packs as you need, and they will be merged together. Okay, so I cleaned things up a bit, and I'm going to show you the last option that you can use with resource packs and data packs. So the render option allows you to process any text file inside of a data pack and a resource pack with Jinja. And Jinja is a really powerful and really popular templating engine. So let's say I want to render functions. Here I can specify a list of glob patterns. So this will say that any function that's located inside of the demo namespace, I want to process it with Jinja. So to experiment with this a bit, I'm going to interpolate an expression here. And if we run this, you're going to see that the generated function has the interpolated value inside of it. So I'm not going to go into a lot of details about this. You can check out how Jinja works on the official website, but everything kind of works just as you would expect. You can use base templates, you can use template blocks, you can extend from templates, you can declare macros, you can do everything that Jinja does basically. The only thing is that if you use the line block syntax, the prefix is not simply this, it's configured to be a hash sign and an exclamation mark. Anyway, there's one more thing that you need to know if you're planning to use Beet with templates, and it's that if you're trying to include or extend from a template or import some macros, by default, Beet configured Jinjas to look into the templates directory. In here, so you say foo, and we want to include it in this function. So as you can see, we have the content of the foo.mc function that's placed where the include directive would be. If you want to use a different folder, you can do that by specifying the templates option. So you can give a list of directories that Jinja should look into. So by default, it's set up like this, but maybe you want to separate your macros inside of a separate folder. And now if you declare some macros inside of the macros directory, it's going to work. Okay, so the next one is quite simple. It's the meta option. If you remember on the context object, this meta attribute, basically the meta option allows you to populate this dictionary. So it's useful because you can use this inside of templates, and plugins can use it to expose configuration points, basically. So let's say we have foo, which is 1, 2, 3. Then what we can do, instead of saying say foo, we can say ctx.meta.foo. And we can also use this inside of the plugin, so we can say number is equal to ctx.meta and then foo, and we can say number. So as you can see, the template managed to find the number, and same thing for the plugin. Okay, so we're getting close to the end. I'm going to show you the directory option. So it's not something that you're going to use every day, but it can be useful if you need it. Basically what it does, it allows you to change the directory from which every single path is resolved inside of the config file. So for instance, like this src folder or like templates and macros folder, these are all resolved according to the project directory, and by default the project directory is the directory in which you wrote the config file basically. But if you want to have like multiple config files at the same place and make them refer to projects that are located in other directories, you can use the directory option to basically resolve everything relative to the project directory. So, for instance, this would be the directory in which you would place your templates folder, your src folder, or your macros folder. Again, something that you might not be using every day. Next is the ignore option. It allows you to specify glob patterns that should be ignored by the watch command. So anytime you make a modification to some file inside of the project directory, the watch command is going to pick up this modification and rerun the build. And if you have like specific files that interfere with that, you can specify a glob pattern to exclude them. So kind of the same as the directory option, you probably won't need to use this, especially more so that Beet actually already loads whatever is inside your gitignore. So if you have a Git repository and you're using a gitignore, Beet is already going to ignore everything that you've ignored in your gitignore. So you shouldn't really need to specify this, but again, it's useful if you need to. So I want to make it clear that everything that we've been doing inside of the config file can actually be done with a plugin. It's really interesting because internally Beet actually bootstraps the entire build pipeline with the plugin. So it's a plugin that's responsible for looking through your config file and loading the data packs and resource packs that you need, rendering functions and stuff, and also like running the other plugins that you specified in the pipeline option. And basically, this means that anything that you can do inside of the config file, you can do it with the plugin. And this is really powerful because it allows you to, over time, like kind of find your sweet spot, like the workflow that works for you, and abstract it inside of a plugin. So that any new project that you create, you can just have a beat.json that has your plugin inside of the pipeline, and voila, you just have like a completely customized build system that works for you, that's fully fleshed out, that does what you want, does what you need. And I think it's really powerful. So it's useful to keep that in mind. And it's also useful because it's related to the next config option. So the next config option is the require option. And basically it does exactly the same thing as the pipeline option. So we've seen that every plugin has access to the entire context object, and this means that plugins can do a lot of different things. So some plugins might be generating stuff, others might be transforming or introspecting other things, but you also have plugins that are responsible for setting things up inside of the environment. And one example of such a plugin would be a plugin like this. So this plugin define globals grabs the template environment and defines a global variable. To use this, we would traditionally put it inside of the pipeline like this and say define globals and then use the global inside of a function, for instance. The problem is that if we do this, you're going to see that the global is actually not defined. Like nothing gets substituted here. And the reason is that by the time this plugin executes, the bootstrapping plugin that I just talked about already rendered the functions. So the bootstrapping plugin first loads any data pack or resource pack that you might need, and then it renders anything that you want to render, and then it runs the pipeline. But the problem is that if we define the global after rendering the functions, then it's not going to be available when we actually render the function, and that's why it's not appearing here. So in order to fix that, we can use the require option to run plugins before loading data packs. So the require option is handled before anything else inside of the bootstrapping plugin. So this is where you will put plugins that affect the environment. And typically it's not where you're going to put plugins that generate things or introspect things. It's purely plugins that affect the environment and affect the execution context of other things inside of the build pipeline. So if we run this again, as you can see now we have the message. The last option is extend. It allows you to inherit from other config files. So I'm going to modify this config file to pretend that this one is going to be used just for development. So let's say I have like a link set up to some Minecraft world locally, and when I run Beetwatch, this is the config file that I want to use because it's going to directly dump the data pack into my Minecraft world. I don't really care about having it inside of my project. But now let's say I want to create a release of this data pack. So I'm going to create a Beet release.json like this, and I'm going to extend from the regular Beet.json. But this time I'm going to say that I want the data pack to be zipped. And I also want to use versioning. So let's say this is version 1.2.3. And I'm going to specify an output directory. Like this. And now let's say I want to create a release build. I can use the config option to select the Beet release config file. And now, as you can see, I have a releases folder with a zipped data pack that contains the version number inside of the name. And this is something that I can push to my GitHub repository, for instance. And let's say I make a modification to this function right here. And I want to publish a new version. I can say, okay, this is 1.3.0, for instance. And then I run the release build. And what happens is that a new version of the data pack was generated alongside the old one. And it's the same thing, I can push this to my GitHub repository. And this was a complete overview of all the configuration options that you can use inside of the config file. Congratulations for making it all the way through. Keep in mind that I didn't really get into all the interactions that can happen between all of these configuration options. So for instance, if you use the extend option inside of a sub-pipeline, you can do really interesting things, but I think the video is kind of long enough and it's a bit more of an advanced topic, so I just didn't get into it. But yeah, anyway, if you have more questions, don't hesitate to reach out to me on Twitter or the Minecraft Comments Discord. And yeah, just hope you enjoyed the video. See you soon.